Alright, so in this video, we're going to be talking about how to simplify this kind of complicated expression, fifth root of 320 over the fifth root of 10. This is going to work basically the exact same way that we handled the last example. So how does this work out? The first thing I want to notice is that, well, I could try to use a factor tree to factor this 320. And I would end up with a nice factorization that cancels this fifth root to some extent. And I also have this fifth root of 10 that hopefully I'd like to get rid of if possible. It is definitely, like, if you did do the factor tree route for 320, you would end up with something that cancels out this fifth root of 10. But instead, why don't we make our life easier? Because if I notice, via the quotient rule for radicals, I have a fifth root on the bottom, I have a fifth root on the top. So basically I can write this whole thing as one giant fifth root, allowing me to divide 320 by this 10 here. So if I were to rewrite this, this gives me fifth root of 320 over fifth root of 10. And okay, using the quotient rule, this gives us one giant fifth root of 320 over 10. This only works when you have the same power on the top and bottom, or the same radical in this case. Powers and radicals are the same thing, and that's probably discussed in another video. So 320 divided by 10, well, that's just equal to 32. So I can rewrite this as the fifth root of 32. All right, so now we don't have a quotient to deal with anymore. We can probably factor this guy into something that has clusters of 5 factors. So taking the 32, breaking it down, that's going to be 2 times 16. 16 is 4 times 4. And 4 is 2 times 2. And 4 is 2 times 2. So how about that? I've got exactly 5 2's to work with here. So because of this, all these things are being multiplied, I have 2 to the 5th power. So I can rewrite this 32 as fifth root of 2 to the 5th. Okay? I have a fifth root and a 5th power, and these kill each other. So this gives me exactly 2. This is a really complicated way of writing 2, because they're all equal to each other. So that's how you handle this sort of situation where you have the same radical on top and the same radical on the bottom. Sometimes just simple division can help simplify things tremendously, so you don't have to do 2 factor trees. We only had to do 1 in this case. So with that, we are done. And if you found this video helpful, please smash that like button. I'll see you in the next one.